All right. Okay, today we are doing trig functions for any angle. And again, I really want you to be drawing pictures as you do this stuff. We want to be able to determine the trig ratio of any angle in standard position by relating it to its corresponding acute triangle. And so what happens here is we have an angle on the XY coordinate plane, and we have its initial side, and we would open it up. So in this case, we have an angle in quadrant 2, with the terminal side in quadrant 2. Hello? Oh, I got it. Yep. I just forgot to turn off land school. All right. We have a terminal side in quadrant 2, and so here's that terminal side, and we know that it's passing through a particular point. And so what we're going to do to draw that angle, we draw that angle, and we create what's called a reference triangle. And that reference triangle has to be an acute triangle. And what we do is from that point, we drop an altitude always to the x-axis. Okay, it's important that we drop our altitude the same way. That altitude always goes towards the x-axis. And then what happens is we get our nice little acute triangle. And it is a reference triangle. And that is giving us, it says we went x units this way, so we have this length x, and we get this length y. And we get a triangle that we can now figure out the radius of using the Pythagorean theorem. And this little angle becomes our little reference angle that we're going to use, the angle closest to the origin, okay? And so let theta be an angle in standard form and pxy be a point on the terminal side. The distance from P to the origin is the radius and can be found using leg squared plus leg squared equals hypotenuse squared. So in this case, x squared plus y squared equals the radius squared. It is just the Pythagorean theorem.
My screen was blank.
It should be fixed. Close your browser and reopen. All right. Now, if we're looking from this little reference angle, that little acute angle, we can also find all of our trig ratios. So if we know each side, I can find all my ratios. So looking from my reference angle right here, what would the sign of that reference angle be? Opposite over hypotenuse, so y over r. And what would the cosine ratio be? Adjacent over hypotenuse, so x over r. And then tangent, y over x, opposite over adjacent, y over x. And so it's kind of just a really nice thing. Cosecant is the reciprocal, so what's its ratio? R over y. Secant is going to be r over x, and cotangent is going to be x over y, okay? And it works all over the place, in whatever quadrant we're in, as long as we draw the right triangle, the correct triangle, all right? It's going to be right, but it needs to be correct. Okay, so let's look at number 1. And again, we want to draw a picture. So point P is at 9, negative 12. So I'm going to draw my little coordinate plane here. And point P is a point on the terminal side of an angle in standard position. Find the exact values of all the trig functions of theta. So 9, negative 12. What quadrant is 9, negative 12 in? Fourth quadrant, yeah. So my angle that I'm going to draw starts the initial side on the positive x-axis, and it's opening up all the way around, all the way to this fourth quadrant, and it's going to look something like this. So here is the terminal side of my angle in standard position, and point P is somewhere on here. I'm going to call it right there is point P, and point P is at 9, negative 12. Is my drawing to scale? Of course not, okay? Doesn't have to be. What I need to do, here's my angle theta. That is the whole thing. It's a huge angle. It's bigger than 270 degrees, right? Okay. So what I need to do is I'm going to drop an altitude to the x-axis. We always drop that altitude to the x-axis, and that's going to create my little acute reference triangle. You'll see it denoted as theta prime. That little angle closest to the origin is now our little reference angle that we're going to use to reference our ratios. So what is the length of this horizontal piece?
9.
It has 9 units of length. What is the length of my vertical piece? Negative 12. And yes, we include the signs. Positives and negatives will matter. Okay. I need to know the radius. How can I figure out the radius? Yeah, x squared plus y squared equals the radius squared. So I'm going to do 9 squared plus negative 12 quantity squared equals my radius squared. A 9 squared is 81. What is negative 12 quantity squared? Positive 144. I add those two up, I'm going to get 225. And the square root of that would give me 15. 15. Radii are always positive because it is the radius of a circle, and so radii are always positive. But our x and our y are going to be negative or positive according to where they are. Okay. All right, now that we have that, we have our sides labeled. What is the sign looking from my little reference angle right there? Negative 12 over 15. Yes, always. You don't in calculus.
You don't?
Mm-mm. Yep, but you do in pre-cal.
Are you going to be teaching AP calculus?
That better be.
Okay.
I really like it. It was really great. Did you know I wasn't going to be a math teacher until I took calculus?
Really?
Yeah, it changed my life.
What year was it?
1998. Well, 97, I guess, actually.
Great.
A senior, yeah. Reduces by 3, so negative 4 over 5. What is the cosine looking for my little reference angle? 9 over 15, adjacent over hypotenuse. So 9 over 15, and again, it reduces by 3, so 3 over 5. And then tangent, negative 12 over 9, negative 12 opposite over adjacent. And again, that is going to reduce to negative 4 over 3. This is a 3, 4, 5 triangle, ladies and gentlemen, and all it's been done is scaled up, all right, scaled by a factor of 3. But a 3, 4, 5 is a really good Pythagorean triple. Always occurs, okay? So what's cosecant going to be? Negative 5/4. Secant? 5/3. And cotangent? Good, perfect. Okay, cool. Let's do number 2. So once again, all right. So negative 6, negative 2 is a point on the terminal side of an angle in standard position. So I'm going to draw my angle in standard position. What quadrant is negative 6, negative 2 in? Quadrant 3. So I have my initial side on my positive x-axis. It's opening up, and it's terminating here in quadrant 3. And one of the points on there is -6, -2. And again, this is not to scale at all, but I don't really care. So here's angle theta. Now I need to draw my little baby acute triangle. How do I draw that little cutie? You draw a line. From the dot, where does it go? To the x-axis. We're going to go up, in this case, to the x-axis. Right there. And there's our little reference angle, theta prime, right there between the terminal side and the x-axis. I can label some sides here. What's my horizontal side? What's the length of my horizontal side? -6. What's the length of my vertical side? -2. And then now what do we need to figure out? The hypotenuse, the radius. So -6 quantity squared plus -2 quantity squared equals our radius squared. Ladies and gentlemen, in calculus, if you write -6 squared like this and then write 36, you lost the point because it's mathematically incorrect to go from here to that. Okay? So please practice notation. Plus -2 quantity squared is 4 equals the radius squared. And then that would see, radius squared is 40. Oh, that's radius squared is 40. And then we need to square root both sides. How do we simplify the square root of 40? So 4 times 10. Good. The square root of 4 is 2, and the root 10 stays, the 10 stays. Okay, so my radius is 2 root 10. All right. So now looking from our little baby reference angle right there, theta prime, what's the sine ratio? -2 over 2 square root 10. Yeah, we do have to rationalize that. So I'm going to multiply top and bottom by radical 10. What do you suppose happens with these 2's? Yeah, they reduce to 1, so that's kind of nice. And so we get negative radical 10 over 10. Cosine, according to little baby angle theta, -6 over 2 root 10. Tell me about the 6 and the 2. They can reduce? Yeah, 2 and the 6 reduce. And then I do need to rationalize, so I'm going to multiply by radical 10 on top and bottom. And so we get -3 radical 10 over 10. And tangent, according to my little angle, -2 over -6, which is 1/3. Now, I don't ever like flipping things with a radical already on top. I'm going to go back here. It was -1 over radical 10 originally. You flip that, it's just negative radical 10 over 1. Cosine was originally -3 over radical 10 right there before we rationalized. And if I flip that, that gives me negative radical 10 over 3. All right, so look for the one before you rationalize. This is the key, okay? And then cotangent becomes 3. All right. So when we look at these triangles in standard position, what you'll notice is that based on the quadrant that they fall in, some of our ratios, some of our trig ratios, yes. Yeah, please don't, yeah. You want to take that with you?
I think I'll be fine.
Okay.
You want me to sign out?
Go ahead, just go. All right. Okay. So, according to where they fall in the quadrants, some of them may be negative, and some are going to be positive. So then the question is Is there a way we can maybe predict when are our ratios going to be positive and when are they going to be negative? So why, in number 1 here, why was the sign ratio negative? Because that y coordinate was negative, and that was our opposite side. So everything that had that opposite side is going to be negative. Okay, so there's that opposite side. That had a y that was negative. That's going to give us negative ratios there. All right. What are the ratios going to be if they're out here in quadrant 1? They're all going to be positive, aren't they? Positive, positive. Yeah, Okay. All right. So when you look at this picture, the y is the vertical piece. So the x is negative in which quadrants? 2 and 3. So if we're in quadrants 2 and 3, that uses that x, which means cosine and tangent would end up being negative. Does that make sense to you? Well, in the third quadrant, cosine is going to be negative. Tangent does turn positive. You're right. In quadrant 3, tangent does turn positive. Okay, well, it's kind of nice, but the nice thing is I never memorize any of this crap, okay? I don't memorize it because I drew a picture and I don't have to memorize it, okay? And I don't know about you, but I hate memorizing stuff I don't have to. And the best thing about trig, it's in the name, there's always a triangle. All right, and so the nice thing is when we talk about signs of trig functions, depending on the location of the terminal side, the functions can be positive or negative. And so when we look here in quadrant 1, we know that that little triangle has positive x and a positive y and a positive radius. All the ratios are going to end up being positive. If we're here in quadrant 2, only the middle 2, so what's middle 2? Which ones are going to be positive? Sine is positive, because the radius is always positive. So here we have a positive y, but cosine would be negative. What about tangent? Is tangent going to be? That would be negative as well. So the only one that's positive is sine, and its reciprocal function cosecant. Okay, and so these are all the ones that are positive. Let's look in quadrant 3 here, if I have my little reference triangle. In quadrant 3, let's see, sine opposite over hypotenuse, is that going to be positive or negative? Negative. Cosine adjacent over, that's also negative. What about tangent? Positive. Opposite over adjacent. Negative over a negative is going to give us a positive. So in quadrant 3, tangent is going to be a positive result. And also its reciprocal cotangent. And then in quadrant 4, that y is negative. It's going to have a negative value. So sine would be negative. What's cosine? Positive, because that'd be x over the radius, so that would be a positive. So cosine is positive. And tangent would be negative over positive, so that would be negative as well. All right, so cosine and its reciprocal secant are positive. Well, the nice thing is we do have a little mnemonic to figure that out. You were to remember all students, students, all students take calculus Okay. All students take calculus. The A says in quadrant 1, all are positive. The S in students says sine, and it's reciprocal, are positive. T is tangent is positive, and C in the fourth quadrant is cosine is positive, okay? Now, I don't care about any of that because I always just draw pictures, but for questions like this, it's kind of useful. If cosine is greater than 0, if cosine is positive, which quadrants would our terminal side lie? Quadrant 1, and quadrant 4 is also where cosine is positive. Okay? If, let's not do that. I don't want to do anymore.
And it's all of them have 1.
Yeah, if they're asking for positive. So that one's negative, so it's harder to think of. Let's look at this one. Let's look at number 6. If sine of an angle is less than 0, if sine is negative, let's start just with that. What quadrants are we in where sine is negative? Yeah, sine is that involves that y, that opposite side. So that is these two. So that is quadrants 3 and 4 there for the sine is negative. And cotangent is greater than 0. So that's tangent. Where is tangent positive? 3 and 1. Yeah, tangent is opposite over adjacent. So that's where the signs match. So quadrant 3 and quadrant 1. And yes, what do they have in common? Quadrant 3 is where it must lie. So these are kind of fun questions, but really, I just like the next thing. All right, use the given information to find the exact values of the 5 remaining trig functions of theta. Here we have that the sine of the angle is 8 over 17. Again, I want to draw the picture because it's a trig function. I can draw a triangle. Now they're saying here sine is positive. So what quadrants is sine positive in? 1 and 2. So this is quadrants 1 and 2. But it also says that tangent is less than 0. Where is tangent negative? Yeah, 2 and 4 is where tangent is negative. So that's quadrants 2 and 4. So which quadrant do we need to draw our picture in? Yeah, I got to draw it in quadrant 2. And so that's really important that you can figure out where it goes. So I'm going to draw my initial side. My terminal side is going to end up here in quadrant 2. And just like before, I want to create my little right triangle. So I'm going to drop down in altitude. And it told me that my little reference angle had a sine ratio of 8 over 17. So what can I know on this triangle? The opposite is 8, and the hypotenuse is 17. The radius is 17. So how do we figure out the missing side? It's certainly an x. So let's see. So x squared plus 8 squared equals 17 squared. Leg squared plus leg squared equals the hypotenuse squared. So Pythagorean theorem. 15, yeah. Very good. If you solve for x, we get x equals 15. Now this is where x squared was 225, and in geometry we didn't care, right? But in algebra, pre-cal, we do care. When we take a square root, what do you have to remember when you take a square root? It can be positive or negative, and here we have to apply that knowledge, okay? Because we're in quadrant 2, we know that it's got to be negative. So we have to choose the appropriate sign. Yeah, that's why it's helpful to have the picture, right? So with the picture, I know I'm in, that x is going to be a negative value. All right? So that's why I just draw the picture, and so everything will take care of itself. It's really quite nice. Let's see. So cosine is going to be negative 15 over 17. Tangent, opposite over adjacent, negative 8 over 15. What's cosecant? 17 over 8, the reciprocal of what was given. Secant is hypotenuse over adjacent, so negative 17 over 15. And cotangent is adjacent over opposite, negative 15 over 8. Okay. How are you doing so far? You doing okay? All right, let's do number 9, and then I think we're done. Number 9. So, cosecant is a reciprocal function. What's its reciprocal, friend? Sine. So sine of theta is? I'm going to leave it in unsimplified, though, and that's totally fine like that for now. The reason I needed to do that was because I can draw a better picture. Now, sine is negative. Which quadrants is sine negative in? Yeah, quadrants 3 and 4. Sine is uses that opposite side, and so that's right down here where negative land on both quadrants 3 and 4. It also says cosine is negative. Where is cosine negative?
3.
Yeah, cosine is adjacent over hypotenuse, and the adjacent here is negative in quadrants 2 and 3. So quadrants 2 and 3, so which quadrant are we going to draw it in? Yep, they got 3 in common. So I'm going to draw my angle in standard position, and it's going to terminate in quadrant 3 right there. I'm going to drop my altitude up to the x-axis, very important. And I can label some sides here. What information do I know in this triangle? Square root 5. Where does the... On the y side, the vertical side is negative 2. The radius, the hypotenuse, is radical 5. And yes, we want to use the Pythagorean theorem to figure out the x. So x squared plus negative 2 quantity squared equals root 5 quantity squared. And yes, we can do the math, and Will did it faster than most normal human beings. It's just weird. Okay, I'm going to subtract the 4. I get x squared equals 1, and then we get the square root of that, which is, of course, plus or minus 1. And what should our x be? Negative 1, yes. Okay, so our x is negative because we're in negative land. Okay, the sign is negative 2 over root 5, but of course we need to rationalize that. So negative 2 root 5 over 5. Hopefully you got that pattern and can just get there, right? What's the cosine ratio? Negative 1 over root 5, and then when you rationalize, what do you get? Negative 1 root 5 over 5. Good. Tangent? Negative 2 over negative 1, which is just 2. Secant is going to be, again, for secant, that's the reciprocal of cosine. So I'm going to go back to this unrationalized one and flip that because that's easier. Negative root 5 over 1. And then tangent, cotangent is 1/2. Okay? All right, do you have any questions for me? Is that okay? I don't